Previously, we have separated the typing in of some calculation from the execution of this calculation. And this gave rise to the program which we first write and then execute. The disadvantage is that we don't see what gets executed when we write the program. We have to imagine what will happen. But the big advantage is that we can run the program several times and with different input data. Now, what happens when we give a program to the computer? There are basically two ways to proceed. First, the computer interprets the sentences one by one, producing results. Or second, the program gets first translated to an intermediate language that the computer can interpret directly. This is like interpretation and translation in human languages. So this was first interpretation. Now, compilation. This allows us to make some checks and optimize the resulting code before it is sent to the processor for execution. The intermediate code is directly understood by the hardware. Well, this is a simplification, but let's bear with me. The original program in Java is usually called the source code. And the result of the compilation is in machine code, directly understandable by the processor, by the computer. Since there are many different processors, each with its own language, this means that we have to have compilers for all these different languages. Okay, the way chosen by Java is to introduce a new intermediate language between Java, with the source code, and the machine code, which is called the Java bytecode. And there's a virtual machine called the Java virtual machine that translates the bytecode to the corresponding machine language. To this end, it uses some class libraries that comprise useful code, which is usually also dependent of the machine language. The Java virtual machine, together with the class libraries, is called the Java Runtime Environment, JRE. The advantage of having bytecodes and Java virtual machines is that this bytecode can run directly on different devices, like a computer, a smartphone, and a watch, making the code independent of the platform. This gave rise also to the acronym WORA, Write Once, Run Anywhere. So we have talked about how the source code gets executed. But there's another important part, how the source code gets created. How do we write the programs? For this, we use software again. Typically, one needs an editor to write programs, but we would like to have also help on how to find errors, how to remove them, which is called debugging, and other tools. So such an environment would typically also include many programming tools and a JRE in order to be able to execute and to check the code. An interpreter is a person who listens to another person speaking in one language, mentally translates everything into another language, and then almost simultaneously speaks the content heard in another language. This is a very demanding job because you have to listen and speak simultaneously. A translator's job is a bit less stressful. They take a written text in one language and write it down in another language. But the heart of the task is the same, convert sentences in one language to another language. So we have interpretation and translation. And with programs, we also have the need for conversion, for translation between languages, because programs in Java are not directly understandable by computers. They have to be translated into language they are able to understand. And this is called machine language. We have seen various ways to get to this machine language, either by direct translation of the source code or by translating it to an intermediate language, the bytecode, which the Java virtual machine translates to the machine language of our processor, after including some code from special libraries. Okay, this topic of interpretation, translation, compilation is much more complex than we have presented here. We have just presented here a simplified view for introduction purposes.